السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. تحياتي لكم من منصة البث المباشر وزارة التربية والتعليم. نرحب بكم ومع تحيات فريق المنصة. معكم مستر حسام حسن. نبدأ اليوم إن شاء الله حلقتنا في الكيمستري. النهاردة طبعا هنعمل سولفن لشوية شغل كده خاص احنا خدناه من الاسسمنتس الموجودة في موقع الوزارة من W789. خدنا مختارات مختلفة علشان نبتدي نشتغل فيها. أول سؤال بيقول لك choose the correct answer. All the following are characteristics of electrons except. كل هذه الأشياء اللي بنتكلم عنها all the following are characteristics of electrons except. Number A, they are material particles. They have wave properties. They lose energy when they move from one energy levels to another. They are affected by electric and magnetic fields. So we find number C, they lose energy when they move from one energy levels to another. This is correct. I hear here what is the difference between all the following except they are material particles is correct. They have wave properties is correct. So they lose energy when they move from one energy levels to another. This word is incorrect because the electron doesn't lose any energy or gain any energy. If the electron gain a quantum of energy, so it is transfer from levels to another levels. This is correct. But number C is not correct because the electron is stable when in its main level. So the electrons absorbs energy to move up and emits energy when they move down. They don't always lose energy when change levels. Okay, next questions. In this words, we find Heisenberg uncertainty number one. Heisenberg uncertainty principles applies to protons, not neutrons, electrons, all atomic particles. No. Heisenberg uncertainty principles applies to all things, electrons, principles, and C. So principles to all. Now we have the principle certainty about electrons, because it's called these electrons as the particle, and Heisenberg calls it is impossible to determine the location of electrons and the location of electrons and the speed in the same time. Electron saturation sublevels, which of the following choice is saturated with the largest number of electrons? Orbitals 4f, 2b sublevel, energy level n equals 2, 3d sublevels. We discuss orbital 4f equal to 14, okay, equal to 14. 2b sublevels equal 6 electrons. Energy levels n equal to, so equal to 2 equal to 8 electrons. 3d sublevels equal to saturated by 10 electrons. So the following choice saturated with the largest number of electrons is the D. Why? Because we discuss about the orbitals 4f sublevels, but I mean sublevel 4f or orbital 4f sublevel. No, I mean orbital 4f sublevel, because orbital sublevel 4f equal to 2 electrons, not 14s. 14s for the sublevel. So the correct answer is D. 3D sublevels equal saturated by 10 electrons in this sublevels D. Answer D, why A 3D sublevels has 5 orbitals times 2 electrons in each equal to 10 electrons. 2B has 6 electrons, N equal 2 holes to total the single of 4F orbitals equal holes of 2 electrons. Calculating in this, which of the following formulas can be used to calculate the number of electrons needed to fill the sublevels or the subshell? N squares to N square, 2 brackets to L plus 1, brackets to L plus 1. What is the correct answer in here? After discussions in these questions, we find formulas can be used to calculate the number of electrons for each sublevel. N square for each principal level. 2n square for the saturated number of electrons in each principal level. 2 brackets to L plus 1. This is means if L equal to 1, 2 times 1, 2 plus 1, 3 times 2 equals 6. Okay, if you exchange L by 2 electrons, 2 times 2, 4 plus 1, 5 plus times 2, 10. So this is a number, so the C is the correct answer for these questions. This table have choices for the number of principal levels. Now, which of the following choices expresses the 4 quantum numbers of an electrons in 2py or 2px or 2pz? There's no difference. Now, choice N, L1, ML negative 1, MS positive half or negative half. Okay. Now we find L equal to 1. So the answer D here, 1, 2, N equal to, okay, N equal to, P equal 1, P equal 1, not 0. Okay, this is Py, so Ml equal to 0. And number of electrons may be 1 or 2, so Ms equal to positive half or negative half. Did you understand this? I mean, of these questions with the following choices express the 4 quantum numbers NLM and MS, NLML and MS. N equal to, N equal to, L equal to 1, ML equal to 0, MX equal to positive or negative half. So this is the illustrations of these sublevels 2B. Now, which of the following choices equals the number of orbitals that can be occupied by an electron with the principal quantum number N equal to 5 and magnetic quantum number ML equal to negative 2? Okay, 5, this is the principal number, 5. And magnetic ML negative 2. So negative 2 found in D ML from minus 2 to positive 2 or minus 3 to positive 3. This is negative 2 in this range. Okay, 1 quantum number here and the magnetic number the following choice equal the number of orbitals that can be number of orbitals negative 2 only. Okay, negative 2s having the possibles for L equal to L equal to 2, maybe L equal to 3. We have many probables for L equal 2 or L equal 3. So the answers from 0 to 3. So the quantum numbers here equal to the possible L equal to L, D or F. D or F. We have these orbitals. ML found the N2, D and F. So may here say 3 distinct orbitals. Answer C is this answers for C. Okay? We discussed years ML equal to negative 2. Negative 2 if you discuss D from negative 2 to positive 2 and F from negative 3 to positive 3. So the quantum numbers found in number C. Which of the following choice represents the 4 quantum numbers for the electron in the circle? Where this electrons here, ms negative half. So this is a p, this is a p, okay, p, so L equal to 1. Now px, negative 1, ml equal to negative 1. But this is not correct because this electron rotate in anti-clockwise before distributed of these electrons unpaired before and pairing after. Okay, so these electrons can mean that n equal to this number 25. This is 25 electrons. Okay, choices A, n equal to 1 or 2 or this prepables for L 0 or 1, ml negative 1 or positive 1 or 1, ml ms negative half or positive half. So we have many discussions about this choices. Which of the following choice represents the 4 quantum numbers? A, maybe A. Okay, we find here this electrons and this place equal to, the answer is this choices A, B and C and D for this. So the answer is C. Okay, now in the next we find this is choices. Which of the following choice doesn't describe the electron clouds and orbitals? Doesn't describe. Okay, A region of space surrounding the nucleus where electrons are most, okay, likely to be found 90% to 95%. These electrons may be in these regions, okay, and an area of regions specifies the where electrons not. This is right. It has specific shapes and size. Okay, it's correct. Electron clouds. It has specific shapes and size. It has no clear and specific bounded. Okay, it's part of the electrons cloud. No, C is not correct. It is the sum of all orbitals at an energy levels. No, this is choices is not corrected. It not describe the electron clouds. All the following describe the energy levels n equal 3 except it contains sublevels, it contains 3 sublevels, it is saturated with 18 electrons, its energy is greater than that n equal to 4, it contains 9 electrons. It contains 9 electrons. Answer A, it contains 3 sublevels. 3 sublevels. It's saturated with 18 electrons. It's saturated with 18 electrons. Its energy is greater than that of n equal to 4. Energy is greater than that of n equal to 4. No, this is incorrect. This is incorrect. D contains 9 orbitals. Yes, 3 equal to 9 orbitals. It is saturated with 18, right? Right. It contains 3 sublevels. 3 sublevels. S, B, D. Yes, that's correct. But it's not correct. Its energy is greater than that of n equal to 4. No, it is lower. It is lower than of this n equal to 4. This is incorrect. Next. The number of electrons needed to fill the energy level B equal to 6, 8, 18, 32. This is easy. Its capacity equals 6 electrons only. 6 electrons only. Okay. Next. The following figures represents I'm sorry, so next here we find, I'm sorry. The following figures represents 3 dimensions x, y, z through the orbitals shapes in the main plan n equal to. Now we can do the draw, but we can discuss about these questions. Orbital shapes for n equals 2. This is 2s spherical orbitals with 1 radius nodes. And the others to be, we have 3 dimensions, three dumbbells shapes, orbitals oriented along x direction, y direction, and z directions, each with nodules plans through the nucleus. This following discuss complete that. These examples to discussions the complete following tables 2b, 1s, 4s, 4f, 4d. N allows 1 equals 0 to n negative 1. N negative 1. L allows ml negative 2 to positive, negative 1 to positive 1. Each orbital has 2 electrons with ms equal to positive half. So this completing of these tables, this example, we have this example, this is completed, and this is completed because as 2p, 1s, 4f, 3d. ML equal to negative 1. This is 2b. This is orbital 2b. Negative 1, okay? Okay. Negative 1, positive half, 2b, 1. 2b1, okay. 1 S2, when S2 saturated, okay, or completed. 4f, this is the third, 3 minus 2 minus 1, 3. 4f, 3d, minus 2, 3d. Okay, this is have an electrons we have these orbitals have these electrons. Each electrons found in all orbitals, Question number one in this part, which is saturated with a greater number of electrons, energy level B or energy level B? Energy level B, which one saturated with a greater number of electrons, energy level B or energy level B? We have B sublevels and the principal level. What's the difference? We have K, L, M, N, O, P, Q. What is the difference between P and P? P is the principal level, energy level, but B is a sub-level. P saturated with 6 electrons. P, we don't fix this number, or we don't know the saturated number of electrons in P principal. K, L, M, N, O, P, this number 6. The energy after 4, you can't to determine the saturated number of electrons in each principal levels. The capacity is 6 electrons here. This is capacity of the energy levels but in this capacity may be 2n square. Okay, B, this is BQ fixed 6 regarded less of n. This is answer principal level interpreted a P as is n can hold 2n squares electrons, whereas the P sublevels hold 6 electrons only. Therefore, B can be saturated with more electrons. Okay, we knew the difference between this electrons in P sublevel or P sublevel or P this principal levels. State scientific reasons for each of the following. The rule 2n squares doesn't apply to the levels if sublevel is filled with 14 electrons. 2n square. Scientific reasons for this. Number one, we discussed the rule 2n square doesn't apply to levels after the fourth. For high chill sublevels, energies overlapping between adjacent shells and actual filling follows these n+1 orders or according to off-bow. As a result, shell beyond n equal to 4 don't reach their theoretical 2n square capacity is in ground state atoms. So the sublevels F filled with 14 electrons for L equals 3, number of orbitals equal to L+1 equals 7 orbital. Each orbital saturated by 2 electrons, so the number of electrons in this sublevel equal to 14. There is numbers 2D sublevels. This is not found. We have no 2D. Okay. Write possible values for L and ML for electrons n equals 3. L and ML for the electron n equal to 3. For n equals 3, L equal to 0, 1, 2. Okay, and this is a principal level, n equal to 3. This is principal level. We have SBD. S equal to 0, L, and the principal level, this same principal level, P, L equal to 1, and D, L equal to 2. So ML in the first equal to 0, ML equal to -1, 0, and +1, and L equal to 2, ML from -2 to +2, -2, and -1, 0, +1, and +2. Compare second, third main energy. Okay. Compare the second and third main energy levels in terms of A. Their symbols be the same. The numbers of electrons needed to saturated, and their sublevels, the number of orbitals in each electron, their radius of their energy. Okay. N equal to 3. I mean, the third shell or the third principal levels. Principal levels. The symbols here is KLM. M the third, the L is the second. Okay, electrons is saturated. Number N equal to 8 electrons because it applies to N squares. And M shells 18 electrons when applied to N square. Sublevels in number 2, 4 sublevels is 2s and 2b, and the third is 3s, 3b, and 3d. A number of orbitals in n equal to 4, because we can to apply n square rules, and the n equal to 3. We have 9 orbitals because we can to apply n square rules. Radius smaller, and this n equal to the radius n equal to 3 larger. Energy lower in n equal to, the energy is higher in n equal to 3. Okay, we can complete these diagrams. Which of these diagrams is correct for each one? This diagram relations between the atomic numbers and the number of single electrons in these atoms. Okay, we discuss this by electronic distributions or electronic configurations for each atoms from 20 to 30. Okay, we find the number of single electrons increase. Single electrons is increased. This is in calcium 20. This number of amperes is 0. 21 is 1. 22 is 2. 23 is 3. 24 is 6. 25 is 5, 26 is 4, 27 is 3, 28 is 2, 10 is 0 and 0. So we can to choose this is not right, this is not right, this is right because we have 6 electrons. But here is 5, his is more, is 6 and stable in 6 and stable in 5. This is incorrect. This is incorrect. This is incorrect because the number of single electrons or unpaired electron doesn't stable, but it changes from 0 to highest number is 6 and decreases to 0 again. Okay, this is which following graph is correct. I discussed before. This is the electrons 2 6 as z equal 24s. Manganese and the decreasing for this is chromium z equal 24, the manganese equal 25. So the curve was we choosing before in this diagram, in the last diagram. An element X contain number of electrons in sublevel for S equal to number of electrons in 3D. Okay, this is filled with 2. So 3D equals to 2. Okay, this is number of electrons in D equal to Y because S saturated with 2 or 1. Okay, or 1 or D is 5, S1. But we have this is 2 and D equals 2. So the electronic configuration of X positive 2. Positive 2. This is electrons lose 2 electrons. Lose 2 electrons from the outermost of the sub levels. The sub levels. So we have equal to 3D2. Why? Because 4S is 0. Now we can discuss that the atom when it lose two electrons, it electrons from the farthest sublevels, I mean 4s. I mean 4s. So the true or correct answer is C. 1s2, 2s2, 2b6, 3s2, 3b6, 3d2. Okay. The elements in which all 8 electrons are distributed in 6 completed energy sublevels, its atomic number is, okay. Now you must, after choosing discussion, to translate the concept of these questions, elements in which all its electrons are distributed in 6, okay, 1s2, okay, number 2, 2s2, and 3 and 2b6, 3s2, 3b6, okay, 4s2. Now we have 6 sublevels, 6 completed energy, but the last 4s2 is not completed. We have 5 sublevel completed. Atomic number is, you can to choose the rights, 1, 10, or 18, or 20. This answer is 18. Why? I called before 1s2, 2s2, 2b6, 3s2, 3s2, 2s2, 2b6, 3s2, 3b6, 4s2. But I mean filled only 6 completed energy. You have 4s2. This is the number of electrons, 18. Y 6 completed sublevel up to 3b6, because is the elements which all its electrons distributed in 6 completed energy sublevels, its atomic number. This is atoms. Atomic of an element contain one single electron in B sublevel, so its atomic number equals to 12 or 15, 31 or 17, 14 or 15, 11 or 14. Atoms, one single electrons. I have 2 propables for one single electrons. In B, maybe P1 and maybe P5. P1 and P5. Okay. P1 maybe 31, maybe 31, and maybe 35, and maybe 14, maybe 17, because 31 is 3b, sorry, not 3b, 4b1, but 17 is 3b5. Different principal levels, but is correct, because I search about the P have one unpaired electron, one electron only. Okay. Last electron quantum numbers. Okay, the 4 quantum numbers for the last electrons in atom equal 3, L equal to 1, ML equal to -2, MS equal to positive half. So atomic number is, okay, translate 3D, 3D1, 3D1. Now I translate 3D1 because N equal to 3, L equal to 2, ML equal to -2. I mean the first orbital in D. MS equal to positive half, so the number of electrons equal to D5. D1, I'm sorry, D1. So for S2, 3D1 equal 21 electrons. The last electrons is 3D1 secondium, Z equal 21. Which of the following represents the number of orbitals partially filled with electrons for an electron with atomic number 19? We have four choices: A1, B7, C10, and D is equal to 15. Now this answers is 19. 19, the number 19. 19 is 4s1. Argon 18, 4s1. So the electrons for the elements with atomic numbers 19 is 1. 1 is K19, argon 4s2, only one partially filled only, and the last is filled by electrons. Which the following diagrams show the correct distributions of electrons in the last energy levels of oxygen atom. Oxygen atom distributed helium 2, helium atomic numbers 2, 2s2, 2b4, 2s2, 2b4. Okay, 2b4 distributed in 3 orbitals b, 3 orbitals b, bx2, bx, by1, bz1. Okay, choose the true answer here. We find the diagram with 2s, and we find that the first chooses, we show this is not true, this is not true, this is true. This is a correct answer. Okay, because we have empty orbitals, and pair of this electron is not correct. We have 2 electrons in one orbital in the same rotation around itself. This is incorrect because we have one single electron rotation in anti-clockwise direction. But here is true. Okay, next, if you know that the sum of spin quantum number of electrons of an element equal 3. Okay, this is mathematical equations, because ms equal to positive half or negative half. Positive half or negative half. Positive 3, I mean positive 3. This is 3 is positive, not direction is positive, by the summation equal to positive 3. Okay, we have 6 positive half. Okay, we have 6 positive half. So we have 6 single electrons. Okay, we have 6 single electrons. The single electrons doesn't found in any electron except the 6p, 6b. I mean 6b, the 6th column in the periodic table, a quantum number of it's equal 24. Okay, you can to distribute 24 to know we have 4s1, okay, single, 3d5, 5 single, each one equal to positive half, positive half, positive half, positive half. We have 6 positive half times 6 equal to summation is 3. Copper 1 configurations, electronic distribution of X positive 1 ions whose nucleus contains 29. 29 is copper. 29 protons. Now we have some choices. 1s2, 2s2, 2b6, 3s2, 3b6, 3d9. This is incorrect. This is incorrect because the electronic configuration of copper is 4s1, 3d10. 4s1, 3d10. If it lose one electron from s, then the number of electrons in d equal to 10 and 4s equal to 0. So the answer is 1s2, 2s2, 2b6, 3s2, 3b6, 3d10. Where is 4s? 4s equal to 0. So is not found here. No electrons in 4s. So the C is correct answer. What are the quantum number whose values never be negative? Principal or secondary, principal and spin, magnetic and subsidiaries, magnetics and spin. So A is not negative, principal is not negative, and the same L is not negative. N ranged from 1 to 7. L ranged from 0 to 3. Now we have probabilities of the numbers. We have no negative number on these choices. Now we finished these questions. I discussed this before, and I hope you a nice day. Thank you for good listening, and see you later in next session, inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.